All right, so let's return to our Lego data for one more ANOVA example, especially if you decide that you want to explore something in this realm for your final project. So ANOVA, again, we're looking at a numeric variable from multiple populations, right? So you might think of this as just a numeric variable versus a categorical variable where we have more than two categories. And so I'm thinking again about our uh, those themes, right? We were looking at like Friends versus Star Wars and seeing if the price was similar across them. And before we didn't have a test to do that, we were just looking at box plots and summary statistics and trying to sort of see, is there a difference in price point depending on which kind of Lego you're grabbing. So let's go ahead and do ANOVA. If we're gonna do a test, first thing we should do is check our assumptions. So let's review what those assumptions were for ANOVA. In fact, let me get myself a new screen and bring those over so that we have them. Boom, here are my conditions. I'm going to make them way bigger. All right. We need each of the K populations or treatment responses to be normal, normally distributed. So when we're talking about this, our populations are going to be the different types of Lego sets, and we're going to look at that price as our thing. So let's pull up my Lego data. We could, of course, do a dot plot or a histogram. We don't have a huge amount of data, but those can be really tricky to see if we're violating normality. So I'm going to use a QQ plot. So we're going to go over to graphs, QQ plot. I'm going to look at price, and we're going to group this by our theme. But of course, we want to make sure that we're only using those larger groups, right? We had way too many themes in here. So this is me saying, okay, I'm only going to look at those like four groups we looked at before, those four different types of themes, where we had, I think my like cutoff was like 100. I don't remember what the number was. And we're going to go ahead and look at these QQ plots. So we can see we have a bunch of QQ plots. A QQ plot, theoretically, our points, if we have a normal distribution or a normally distributed variable for a little sample, and this is just for a sample, right? But usually our sample is representative of our population. It should follow the line. So this is looking like we're violating normality with the city date ones, Friends, Ninjago, and Star Wars. Every single one of these is violating normality. And if we wanted to see sort of why, we might look at our histogram and do the exact same thing. Let's go look at price by the theme. Oops, I grabbed the wrong one. By theme, and let's tell it we only want the larger sets. And yeah, we can see, oh, yeah, every single one of these distributions is skewed to the right. This is why those QQ plots have such a great departure from that line we would expect to see if these were normal. Um, so right now, right off the bat, we're going, conditions wise, it's not looking good for us. We did not meet this condition. it We have this departure from normality because our data in those QQ plots doesn't seem to fit a normal distribution. Um, you notice I'm not using the word linear because a lot of students will get those QQ plots that we just saw confused with our scatter plots. It is not a scatter plot. This is not anything we can talk about in any of the words that we use scatter. I mean, it is a scatter plot, right? But it's not a scatter plot in the traditional sense. We can't say there's a linear relationship or anything like that. What we want to see is just do these things, follow that line, and if they do, that means that that variable price for this group, which is Star Wars, is roughly normally distributed. And since they don't follow that line, we know that they're not, and we violated that first condition. All right, so let's go see if maybe we get the second one. They have an equal standard deviation. There's as much variability for each of the types of sets in terms of price. So to test this, this is actually something that's going to happen with our ANOVA. We'll go to stat, ANOVA, one way. Oof, this is going to be a pain. We're going to try. Okay, so we still need our larger yes. Thank you. Our values are in a single column. Otherwise, we might have like two columns, like a column per group, but we have one column with price and another column to tell us what type of set it is. So the price is the response. That's the thing we want to see as our outcome variable. And our different groups, or factors in this case, are our themes. And you'll see, you can do a lot of stuff. We get a QQ plot, blah, blah, blah. One of the options, I think it just gives it to me. Oh, here, no. Is to do a test for homogeneity of variance. And so I know this doesn't sound like what we're doing here with these equal standard deviations, But that's exactly what this is doing. Homogeneity means equivalency, right? Like very similarness. And then variance is another way to talk about the spread or our standard deviation squared. So if we have a similar standard deviation squared, that means our standard deviations are equal. So I'm going to press compute. So we do have a p-value for ANOVA. We also get a p-value for this test for our homogeneity of variance. And this is where we get our first of sort of like this weird situation. Because what we want for a condition is we actually would like it if the standard deviations are equal. And this is just like our chi-square test for goodness of fit. Our null hypothesis for this test for homogeneity is that all of the standard deviations are the same. So the fact that we have a tiny p-value here means that we would reject this null that they're all the same. So we also fail to meet this. In fact, we could even, and some students have Googled it and come up with other ways. I think there's like a ratio of the standard deviations that students will use. We can look at this Lego data. We can look at the standard deviations on these. We can see like, oh my gosh, Star Wars' standard deviation is 85 versus Friends' standard deviation is 24. So like, I think if that ratio is more than a 3-to-1 or there's some number that you will find on Google that some people use rather than doing this test for homogeneity, you could say, yeah, that there's no way those have the same variances when you look at the actual values there. And that kind of makes sense. Most of the Friends Lego sets are for children and therefore not going to get super duper expensive. Whereas Star Wars Lego sets, you've got everything from the little 4+ tiny things to like the, $800 Millennium Falcon or whatever. So this makes sense logically as well. But right now we're just failing to be able to do ANOVA. Last two, these we don't need any StatCrunch to check, are observations in each sample are independent. So that means that like the price of one Lego Star Wars set does not influence the price of another Lego Star Wars set. Assuming that Anna and who was the other woman? Anna and Laura, the women who collected that Lego data, did this in either a random sample. There's not really much of a reason one should influence the next. So we're probably okay here. We would have liked it even better if they said we took a random sample, but that's okay. I'm gonna give us this one because I want us to put a check mark somewhere. And then the samples are selected independently from one another or random assignment has been made. Again, I didn't read their entire article about how they selected this Lego data. But yeah, I mean, theoretically, you'd want to take like of all the Legos that are Star Wars, take a random sample from that population. Of all the Legos that are Friends, take a random sample from that population. We tend to end up violating this in most of the analyses we will do in our projects and whatnot, because we start with one sample and then we just divide based on some categorical variable. And it wasn't as though we took a random sample of, say, people who identified as female and people who identified as male. We instead took a random sample of people and then asked them that question. So then we don't really get that last point. So very, very infrequently are we actually going to be able to check that last one in the way that we are doing things in our class, right? There's an experiment, sure, we got random assignment. But like I said, these are some pretty strict and hard to meet conditions for ANOVA, which is why a lot of people really like all the non-parametric stuff that's like beyond intro stats. So what we're going to do is we're going to do exactly what you're going to do with all of your little final project pieces here. And we are going to proceed with caution. We're going to say, yeah, I get it. My conditions were not met, but I'd still like to be able to like look at this data. I still feel like glancing at this data, there's a difference between the different types of sets. And I know I'm going to put a big asterisk on my final thing I'm going to say, but I'm going to proceed anyways. So we're going to keep going. And then we go, okay, well, let's go ahead and write out our hypotheses. Now, this is one that really students really struggle with if they choose to do a project on a quantitative or a numeric versus a categorical. So let's just pull these up and rewrite them for our situation. Get my face out of the way. There we go. All right, so in this case, the true means of our numeric variable. Okay, so let's just write it out. The true means of our numeric variable. All right, the true average or mean, I'm just going to use average. I don't know why I'm doing that, but it's too late now. Average price for a Lego set is the same for all themes. And we should be clear here that we're only testing these certain ones: Star Wars, Friends, City. What was the last one? Oh, Ninjago. All right, so you'll note we replace the numeric variable with what it is, price of a Lego set, and we replace that populations or treatments with what we were talking about, themes. Cool? And so our alternative, same, except for difference. At least one of those means is different. And I'll just write that a little bit cleaner because my pen is hating me. At least one theme has a different average price. So it's very similar to our situation in the chi-squared test for homogeneity, where it was like one of the strategies was different than the others. We're not saying, oh, hey, Star Wars is going to be the most expensive or anything like that. We're just saying one of them is different. And at the end, that's all we'll be able to say. So let's go ahead and grab our output from our ANOVA. So we already used this p-value when looking at how we did not have equal variances. But now we actually want to reject, and we are using the ANOVA table to do that. So we'll come over here. Our ANOVA table has a p-value that is extremely small. This is smaller than any reasonable alpha. So we would reject the null. All right. So this is telling us there is enough. Let me use my typey one again and then make that bigger. The last time that was disastrous when I tried to write it. All right. There is enough evidence to conclude that the average price of a Lego set is not the same for all themes. And then Star Wars, Ninjago, Friends, and City. Or we could even be like across the same for the following themes. There we go. That's cute. All right, so that's our conclusion. We're done. That's it. Again, we probably want to do something ad hoc because it's just what we want to do as people like say more about it. Of course, there's a big fat asterisk on this, like knowing, of course, we violated a ton of assumptions in order to get this data, but this is just like, okay, I did some preliminary analysis. Somebody who's more sophisticated has some non-parametric techniques, can get away from those issues. Let me know. But we can look here too and see these means. And again, we're like, okay, 60 is way different than these other two. Like maybe if Star Wars wasn't in the mix, we might not have such a strong p-value. But with Star Wars in there, that's what we're seeing. It's a way more challenging to drop Star Wars from this. Unfortunately, in StatCrunch, in like R, it'd be way easier for me to subset. But I am gonna just say with that. But yeah, so this is ANOVA from start to finish. You should be checking your conditions. Hopefully, you don't have so many violations as we did. You should be then writing up these hypotheses, replacing the numeric variable in our categories, and then looking at the output from your ANOVA table and writing up your sentence. And then, of course, you can go further to say it looks like of all those sets, Star Wars is a little bit more expensive. Obviously, we would want to do probably some other analysis, but it's just going to be a pain in the butt to do that in StatCrunch.